For today's lesson, we're going to be discussing chemical bonding. In our last unit, we talked about separate atoms and how many protons, neutrons, and electrons they have. In this unit, we're going to be discussing what happens when two of those atoms come together to form a compound through a chemical bond. So a chemical bond is just the attraction between electrons and protons of different atoms. So atom A and atom B are going to be pulled together in a bond based on that attraction. So we can form a bond by either transferring or sharing electrons, but electrons are key in our chemical bonding. So there are two types we're going to talk about, ionic bonds and covalent bonds. So ionic bonds are going to form when electrons are transferred. So as we look at this example down here, we see sodium and chlorine are two atoms that are going to come together to form our bond. Sodium is going to give up one of its electrons in its outer ring, and it's going to donate it to chlorine. So sodium becomes a plus charge now because it's lost an electron, and chlorine becomes a negatively charged atom. And that positive and negative are going to attract to form our bond. So transferring electrons forms ionic bonds. Covalent bonds form from sharing electrons. So here we have two hydrogen atoms, both with an electron in their outer ring, and they're going to share those two electrons, and that sharing of electrons forms the chemical bond. So why do things want to bond? What's the purpose? And so most things in nature want to have low energy. They don't want to be very reactive, and they want to be stable. So by gaining, sharing, and losing electrons, atoms can become stable, and they do this in a chemical bond. So what makes something stable? We have a rule called the octet rule, which says everything wants, with two exceptions, to have 8 electrons in their outermost ring, and having those 8 electrons makes it stable. The two exceptions are hydrogen and helium, the two smallest atoms. They only need 2 electrons in their outer ring to be stable. But if we look at A, B, and C here, we have 3 different atoms. Let's see if we can figure out which ones are going to be stable and which ones are going to need to form a bond. So atom A, we have 1, 2, 3, 4, 5, 6, 7, 8 electrons in our outermost ring. So that fits our octet rule. Having 8 makes it stable. So A is stable. Let's look at atom B. Atom B only has 1 electron in its outermost ring. So it is not stable. So it would want to form a bond to become stable. In most cases, it will lose this electron, give it away to another atom, and now it will have 1, 2, 3, 4, 5, 6, 7, 8 in its outermost ring. Then it would be stable. But right now, with that 1 in the outermost ring, it is not. Let's look at atom C. So atom C has 1, 2, 3, 4, 5, 6, 7, 8. So it also has 8, so it would be stable. It meets our octet rule. So let's look a little bit closely at these types of bonds. So when ionic bonds form, we have a positive and a negative atom coming together. And so it always forms between a metal and a nonmetal. Now, if you remember from our last little lesson, you colored your periodic table. So for an ionic bond to form, we need an atom from the metal region, which will form our positive one, and we need a nonmetal from our other region, and that will form our negative atom. So a metal and a nonmetal coming together forms our ionic bond. The covalent bonds are formed from sharing, and they occur between nonmetals. So we need atoms from the nonmetal region to form a covalent bond. So if they are shared unequally, so meaning one atom likes to hog the electrons more than the other atom, we would form a polar covalent molecule. So some of the electrons are going to spend more time around one atom than around our other atom. And so we get this weird shaped electron area. Polar covalent things, the electrons are shared equally. So we get this nice evenly distributed electron cloud. So how do we know? Just by looking at two atoms, what type of bond they'll form. So we calculate something called an electronegativity difference. So an electronegativity value tells us how well an element can attract electrons to itself. So if we subtract the two values and we get a number that's 2 or greater, then it will be an ionic compound. If we get a number that's between 0.6 and 1.9, that makes it polar covalent. And if we get something 0.5 or less, that makes it a nonpolar covalent molecule. So where do we find these values? So you should have a little periodic table with these values listed on it. So let's try using it. Let's figure out what kind of bond will form between a hydrogen and sulfur atom. So we find hydrogen, we find sulfur on our little chart. So we get 2.5 for sulfur. We're going to subtract it from hydrogen, which is 2.1. And we get a difference of 0.4. It doesn't matter what order you write them in. It's always the highest value minus the smaller value. You always want to get a positive number out. So this one makes it nonpolar covalent. Okay, let's try another one. So C, E, and F. So F is way up here. Fluorine has the highest value of 4. We're going to subtract it from Ce, is way down here in the other corner. We get 1.1. Now if we subtract those two on our calculator, so 4 minus 1.1, we get 2.9. So this one is above 2, so that makes it ionic. Let's try the next one. So carbon and chlorine. So chlorine has a value of 3. Carbon has a value of 2.5. We subtract the 2 in our calculator, we get 0.5, making it nonpolar covalent. Let's try number 4. So we have calcium and chlorine. So chlorine we just found was 3. And calcium's over on the other side, we get a 1. Making it 2. So 2 or greater is ionic. Let's try number 5. So we have 2 oxygen atoms that are going to form a bond. So oxygen is 3.5. Subtracting it from 3.5, we get a difference of 0. Making it nonpolar covalent. And then our last one, we have a chlorine and a bromine. So chlorine is 3.0, bromine is 2.8. Subtract the 2, and we get a difference of 0.2. Also making this one nonpolar covalent. Again, we're always taking the highest one minus the smallest one to get our difference. So next you're going to be working on a lab where you're going to observe some properties of ionic and covalent compounds. And you're going to fill this chart in after you've conducted that experiment.